So hello, my name is Dexter Norris, and I was responsible for creating the sensor package for our Smart Rockets project.
Hello, my name is Blaine Timunganwa, and I was in charge of the general design and construction of the rocket.
Hello, my name is Jesse Lamb, and I was in charge of the parachute design for a rocket.
So here's a brief outline of what our presentation will look like. First, we have our introduction, then our results, our rationale, and finally our conclusion. So our project was split into two main stages, an alpha stage and a beta stage. In the alpha stage, we used an Arduino Uno to create a sensor that would be able to collect atmospheric data as well as flight data.
In the beta stage of the project, the goal was to create a rocket that is a self-deploying parachute at Apogee. This consisted of three parts: the rocket itself, the parachute deploy system, and the sensor package, which detects when we are at Apogee. This used an Arduino Nano as well.
Here we have a video of a failed launch. As you can see, the propulsion system works great, it flies really high, but the parachute doesn't deploy and it crashes.
Here's a video of our first successful launch. This is where our parachute deployment system and our rocket propulsion system worked perfectly.
This is a successful launch of a launch at Apogee. So in this launch, we are testing the parachute deploy system, the rocket, and the sensor package that detects when we are at Apogee. The previous launch was just to test the rocket and the parachute deploy system. So when we were reflecting on what we learned through the project, the main thing that I learned was trial and error. So I had initially our theoretical models and designs for a rocket, and through trial and error tests and controlled tests, we would test certain parameters in the rocket, such as the material, this nose cone, or the parachute deploy system, and we would change one thing at a time to find the optimal rocket design that would reach the highest altitudes and successfully collect our data and release our parachute at Apogee.
One of the main things that I learned was about Arduino compatibility and how to interface a design that you designed for one Arduino board and put it onto a different board.
So when I was creating the sensor package, I improved my soldering skills and I became more familiar with Arduino libraries. So our sensor package contains primarily two main sensors, the barometer and an accelerometer. These sensors measure temperature, altitude, pressure, and acceleration. We also had an SD card on our sensor so that we could record this data in real time and view it later. And if you look here, we have a graph of our data that we collected from our alpha stage of our project.
So our rocket was not a true rocket with its own independent propulsion system. It was actually launched out of a compressor cannon. And so at the beginning of the project, we had a target altitude that we wanted to hit, and to achieve that, we had to take into consideration the force coming out of the cannon, the mass of the rocket, and the drag. And so we calculated mass and how all that played into our altitude. And we also experimented with different nose cone designs and hull materials.
So lastly, I'll be explaining how our parachute deploy system works. So the parachute deploy system starts with a sensor that is based off of the pressure. As we decrease in elevation, we increase in pressure. And the sensor will then detect that increase in pressure and send a signal to the servo motor. The servo motor will then rotate 180 degrees, which releases the elastic band that is attached to it. And the elastic band is holding on the parachute. When the elastic band is released, the parachute will deploy and we'll have a safe descent down. Now for our project, we used a pressure-based Apogee detector, but Blaine also created an acceleration-based Apogee sensor.
So a pressure-based Apogee sensor is really good for detecting when an object goes up and starts to fall back down again, but it cannot measure speed or at what point of the launch the rocket is at, but the accelerometer can. So if you have a parachute that takes super long to deploy and you actually want it to deploy right before Apogee, it's really easy to map where in the launch you are and set it to deploy there.
So in conclusion, a few of the things that would make our project go smoother in the future would be to have a better Arduino Nano and more reliable sensors. A lot of the times our nanos and sensors were breaking down, and this took up a lot of our time to run tests to figure out which sensor was not working or if the Arduino Nano itself wasn't working. So Dexter had to do a lot of soldering to make all these adjustments, and I think if we had more time to focus on integration, which was the hardest part of the project, where we combined our sensor our rocket, and our parachute deploy system, we would have a more successful project in the future.
What's next? The main things that we could improve are is altitude, and to do that we'd have to fiddle with the mass of our rocket and trying to slim everything down to get more exciting data.
That concludes our presentation.
Thank you
Thank
very
you.
much.
Thank you.